So in this video we're just going to be doing some examples of using Euler's form to figure out the values of some pretty odd expressions. So we're going to start with e to the I here. Well, let me just remind us of what Euler's form is. So it's e to the I theta equals cis theta. So we can use this here because this tells us that this is e to the I times 1. So that means this is going to be cis of 1, which is equal to cosine of 1 plus I sine of 1. And so when you plug that into your calculator, that comes out to approximately 0.540 plus 0.841 I. 3 to the I, we're going to do it a little differently. We remember, in order to use Euler's form, we have to get an e in there. So what we can do is do e to the ln of 3 to the I, because that will, these will cancel, this still means the same thing, but we got an e in there, which is what we need for Euler's form. And so we can swing the I to the front, e to the power of I ln of 3, and that just means that theta is ln of 3, so this is cis of ln of 3, which is equal to the cosine of ln of 3 plus I sine of ln of 3. And that will come out to approximately 0.455 plus 0.891 I. Now for I to the power of I, we note that I is a complex number. So we can rewrite I as e to the power of I pi halves, because this is cis of pi halves, and cis of pi halves is just 1. So that tells us then that that's valid, and then since this is an exponent, we can multiply it down to get e to the I squared pi halves, which means this is just e to the negative pi halves. And since there's no I, we can't simplify that any further. If this was e to the negative pi halves I, then this would be negative I. But this is really just a constant, not a complex number. So then for this problem, we can use that finding to substitute in for I to the power of I. So that gives us e to the negative pi halves to the power of I squared, and we can just multiply all these powers together to give us e to the negative pi I, which we know is equal to cis of negative pi, which is just negative 1. And so that is how you use Euler's form to simplify more complicated expressions.